I'm going to ask you three simple questions. Can you answer them? Are you moving right now? Can you travel a long distance but end up with zero displacement? And here's the most surprising one. Why would you weigh much less on the moon even though your body hasn't changed at all? These might sound like tricky questions, but by the end of this lesson, you'll know the answers to all of them. So let's dive into the amazing world of motion. We'll learn how to identify when an object is in rest or motion, discover the different types of motion, understand the difference between uniform and non-uniform motion, and see how distance, speed, average speed helps us to measure motion. We'll also compare mass and weight using simple and real-life examples. So let's get started and discover how motion is happening all around us. Now imagine it's Monday morning. You're rushing to school. Your school bus is moving. The birds are flying overhead. Your friend is running to catch the bus. And when you reach the classroom, the fan is spinning. Have you ever wondered what all of these things have in common? They're all moving. In science, we call this motion. By the end of today's lesson, you'll be able to identify different types of motion all around you, from a cricket ball to a Ferris wheel. And here's your first challenge. Can you think of one moving object around you right now? Let me know your answer in the comment section below. Let's play a quick game. Imagine you're sitting inside a moving bus. Are you moving or are you at rest? The answer is both. To your friend sitting beside you, you are at rest. But to someone standing outside on the road, you're moving. This is because we compare motion with something called as a reference point. A reference point is a fixed object or a place used to determine whether another object is moving or at rest. Now let's understand these two terms. An object is said to be at rest if it does not change its position with respect to the reference point over a period of time. For example, a parked bicycle outside your house is at rest. An object is said to be in motion if it changes its position with respect to the reference point over time. Once someone starts riding the bicycle, it is in motion. Now let's take a look at the different types of motion. And let's understand the different ways objects move. Translatory motion. Translatory motion is a motion in which every part of an object moves in the same distance and in the same direction. Imagine pushing a suitcase across the airport floor. The entire suitcase moves along with you together. That's translatory motion. Rectilinear motion. Rectilinear motion is translatory motion along a straight line path. Walking along a straight school corridor, an elevator moving up, or a train traveling on a straight railway track are all examples of rectilinear motion. Curvilinear motion. Curvilinear motion is translatory motion along a curved path. Throw a basketball towards the hoop. Does it travel in a straight line? No, it follows a curved path. Likewise, if you throw a javelin on the field or water coming out of a fountain are also good examples of curvilinear motion. Rotatory motion. Rotatory motion is the motion in which an object rotates about a fixed axis. Can you think of an example around you? Look up at the classroom fan. It rotates around a fixed rod called its axis. The other examples of rotatory motion are a potter's wheel, a bicycle pedal, and the earth rotating on its axis. Can you think of any other rotating objects? Oscillatory motion. Oscillatory motion is the repeated to and fro motion of an object about its mean position. Remember the playground swing? It moves forward and backward repeatedly. A pendulum is another example. Circular motion. Circular motion is the motion of an object along a circular path. The hands of a clock, a merry-go-round, and satellites moving around the earth all show circular motion. Vibratory motion. Vibratory motion is a very fast to and fro motion of an object about its mean position. Place your fingers gently on your throat while speaking. Can you feel the vibration? Those are your vocal cords vibrating. Similarly, guitar strings and tuning forks also vibrate too. Periodic motion. Periodic motion is a motion that repeats itself after equal intervals of time. As an example, your heartbeat, the Earth's revolution around the sun, and the second hand of a clock are all examples of periodic motion. Non-periodic motion. Non-periodic motion is the motion that does not repeat at regular intervals of time. As an example, traffic. Can you predict that? Lightning or scoring a goal during a football match are all examples. Random motion. Random motion is motion in which the direction keeps changing unpredictably. Watch a butterfly, a fish, dust particles floating in the sunlight. Can you predict where they will go next? Probably not. That's random motion. Combination of motion. Combination of motion occurs when an object shows two or more types of motion at the same period of time. A bicycle moving forward is a perfect example. The bicycle moves forward while its wheels rotate. Can you identify any other object that shows more than one type of motion? Now let us move on to uniform and non-uniform motions. Uniform motion. Uniform motion is when an object covers an equal distance in equal intervals of time. Suppose a train travels exactly at 60 kilometers per hour. Its speed remains constant. That's uniform motion. Non-uniform motion. Non-uniform motion is when an object covers unequal distances in equal intervals of time, or it changes its speeds. Think, think about traveling through city traffic. You stop at signals, you speed up, you slow down, and then you stop again. Which type of motion do you experience while traveling to school? Distance, displacement, and speed. Now let's understand how we measure motion. Distance. Distance is the total length of actual path traveled by an object. Imagine you walk around your school's playground. The entire path you have walked is called the distance. The SI unit of distance is meter. Now let's look at displacement. Displacement is the shortest straight line distance between the starting point and the ending point along the direction. Imagine walking all around the playground and coming back to where you started from. You've traveled quite a lot of distance, but your displacement is zero because your starting point and your ending point are the same. Distance equals the actual path. Displacement equals the shortest path. Speed. Now that we know distance, let's learn how to calculate speed. Speed tells us how fast an object is moving. Scientists calculate speed using a simple formula. Speed is equal to distance divided by time. Let's take an example. Suppose a car takes 100 kilometers in 2 hours. So the speed is equal to 100 divided by 2, which is 50 kilometers per hour. So the SI unit of speed is meter per second, and the other common unit is kilometers per hour. Average speed. But what if the speed changes during the journey? For example, your parents drive slowly in the city, but much faster on the highway. In this case, we calculate something what is called as average speed. Average speed is the total distance traveled divided by the total time taken. Imagine traveling 40 kilometers in the first hour and 60 kilometers in the second hour. The total distance in this case is 100 kilometers and the total time is 2 hours. So your average speed is equal to 100 divided by 2, which is 50 kilometers per hour. Mass and weight. Many people think mass and weight are the same, but they're actually different. What is mass? Mass is the amount of matter present in an object. The mass never changes. Whether you're on Earth, the Moon, in space, your mass remains the same. The SI unit of mass is kilogram, and it is measured using a beam balance. Weight. Weight is the force with which gravity pulls an object towards the Earth or another planet. Because gravity is different on different planets, your weight changes. For example, astronauts feel much lighter on the Moon. Let's understand the formula. Weight is equal to mass into acceleration due to gravity, where W is the weight M is the mass, and G is the acceleration due to gravity. Suppose your mass is 40 kilos. Then your weight is 40 into 9.8, which is 392 newtons. On the moon, gravity is 1/6 of the Earth, so your weight becomes much more smaller, even though your mass of the body is 40 kilos. Did you know Neil Armstrong could jump much higher on the moon because his weight was less and not because his mass had changed? Is the best way to support the channel and keep this kind of content coming. It costs you nothing, but it means the world to revise everything we have learned. We started by understanding that motion means a change in the position of an object with time. While an object is said to be at rest if it does not change its position with respect to a reference point. Next, we learned about the different types of motion. We learned about uniform and non-uniform motion. We also understood the difference between distance displacement. We learned how to calculate speed and average speed using formulas. And finally, we compared mass and weight. So, every time you see a fan spinning, a bus moving, a swing oscillating, or a butterfly flying, try to identify the type of motion. You'll soon realize that physics isn't just a subject in your textbook, it's happening all around you every single day. If this video helped you out, drop a like and subscribe is the best way to support the channel and keep this kind of content coming. It costs you nothing, but it means the world to me.